Hello everyone, I am Josmi Joseph, Assistant Professor of Computer Science. Today we are going to see median for the continuous series. Median is a positional average and its value depends on the position of the frequency distribution. According to L.R. Connor, it is defined as the value of the variable which divides the group into two equal parts. One part comprising all the values greater than median and the other part comprises of all the values less than median. In previous session, we have studied the calculation of median for ungrouped data and for the discrete frequency distribution. Now we are going to see the calculation of median for the continuous frequency distribution. In continuous distribution, we are given with the classes and their respective frequencies. The steps for calculation median for continuous series is: first, prepare the less than cumulative frequency from the frequency distributions given. Then find the value of n by 2, where n is the total number of elements or total frequency. Find the cumulative frequency just greater than n by 2. Now the class corresponding to that is the median class. Use the formula to calculate the median. The formula is median is equal to L plus h by f into n by 2 minus c, where L is the lower limit of the median class, h is the magnitude of the width of the median class. We can find it using the upper limit minus lower limit. And f is the frequency of the median class, n is the total frequency is equal to sigma f, and c is the cumulative frequency of the class preceding the median class. Find the median of the following. The classes, the weights in kilogram of a number of students are given. The classes are 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. And the respective number of students or the frequencies are 3, 5, 20, 10 and 5. Now prepare a table like this where the given classes and their respective frequencies. The total frequency n is equal to sigma f, the sum of all these frequencies, which is 43. Now prepare the cumulative frequency. So for 20 to 30, the cumulative frequency and the frequency both are same. And 30 to 40, the cumulative frequency is 5 plus 3, 8. In 40 to 50, the cumulative frequency is 20 plus 8, 28. For 50 to 60, cumulative frequency is 10 plus 28, 38. For 60 to 80, the cumulative frequency is 5 plus 38, 43. And finally, this value and the total frequency must be same. Now the median is calculated using the formula L plus h by f into n by 2 minus c. First we need to calculate what is n by 2. 43 by 2 is equal to 21.5. Now we need to calculate what is the cumulative frequency just greater than this 21.5. So the cumulative frequency greater than 21.5 is 28. So the class corresponding to this cumulative frequency is 40 to 50. So this is the median class. So the median class is 40 to 50. Now L is the lower limit of the median class, that is 40, and h is the width of the median class, that is 50 minus 40, 10, and f is the frequency of the median class, that is 20, and c is the cumulative frequency preceding the median class. So cumulative frequency precede, this is the median class, cumulative frequency preceding median class is 8. So C is equal to 8. Substitute all these values in the given equation for median, we'll get median is equal to 40 plus 10 by 20 into 43 by 2 minus 8, which is equal to 46.75. Another example. This shows the age distribution of persons in a particular region. Calculate median. Here ages are given, that is below 10, that means from 0 to 10 the number of persons 2, and below 20, that means it is 0 to 20 the number is 5, and below 30, that means 0 to 30 it is 9, below 40, 0 to 40 it is 12, below 50, 0 to 50 the number of persons 14, 0 to 60 15, and 0 to 70 15.5, 70 and above 15.6. Here this is an open-end class. This is having only the lower limit. Here given with is the cumulative frequency. So first we need to find the frequencies from this cumulative frequency, like 0 to 10 how much, then 10 to 20, then 20 to 30, and 30 to 40, 40 to 50, and 50 to 60, 60 to 70, and 70 and above. So for this we can subtract this 5 minus 2, we will get what is in between 10 and 20. And for getting what is between 20 and 30, subtract 5 from 9. 9 minus 5 will give you what is the number of persons between the age 20 and 30, and so on. So preparing the table like this, given ages, and these are the frequencies given. This cumulative frequency is given. So from this we are calculating the frequency. How is, from 0 to 2 what is given is 2, and from 10 to 20 here the cumulative frequency is 5. So 5 minus 2, that is the value of the frequency here, that is the count here. Now for 20 to 30 the cumulative frequency is 9. So 9 minus 5 is 4. For 30 to 40 cumulative frequency 12. 12 minus 9 is 3. And 40 to 50, 14 minus 12, 2. And 50 to 60, 15 minus 14, 1. 60 to 70, 15.5 minus 15 is 0.5. 70 and above, 15.6 minus 15.5, 0.1. Find the sum of all these, will get 15.6, and see this total and this value are same. Now use the formula to find the median as L plus H by F into N by 2 minus C. For this, first find the value of N by 2, which is N is 15.6 by 2 is 15.6 by 2 is 7.8. Now find the cumulative frequency just greater than 7.8. Cumulative frequency just greater than 7.8 is 9. So the class corresponding to that is 20 to 30. So this is the median class. So median class is 20 to 30. And the lower limit of this median class is 20. So the value of L is 20. And H is 30 minus 20, which is 10. And F is the frequency of the median class, which is 4, and C is the cumulative frequency preceding the median class. So cumulative frequency preceding the median class is 5. So C is equal to 5. Now median is equal to, substitute the values, will get 20 plus 10 by 4 into 15.6 minus by 2 minus 5 is 20 plus 10 by 4 into 2.8 is equal to 27 years. Now we can see the importance and the merits and demerits of median. It is easy to understand and easy to calculate, and it is precisely defined. And since it is a positional average, it's not affect extreme observations, but mean always affected by the extreme observation. So compared to that, this is better average in case of extreme observations. It can be computed by dealing with the distribution with open-end classes, as we have seen in the example. Median can sometimes be located by simple inspection and can also be computed graphically, but mean cannot be computed graphically. It is the only average to be used while dealing with the qualitative characteristics. Now the demerits. In case of even number of observations for an ungrouped data, median cannot be determined exactly. We need to calculate the arithmetic mean of the two middle elements. Being a positional average, the exact magnitude of the observations is immaterial. Median is not suitable for further mathematical treatment. That means if we are given with the sizes and median values of different groups or different distributions, we cannot compute the median of the combined group. And it is relatively less stable than median, especially for small samples, since it is affected more by the fluctuations of sampling. So in this session we have seen the calculation of median for the continuous frequency distribution. So here for continuous frequency distribution, it is calculated as L plus H by F into N by 2 minus C, where L is the lower limit of the median class. So median class is found by taking the value N by 2 and then get the cumulative frequency just greater than N by 2. The class corresponding to that cumulative frequency is the median class. So L is the lower limit of the median class and F is the frequency of that median class, H the magnitude or width of the median class, and it can be found using the upper limit minus lower limit of that class, and N is the total frequency and C is the cumulative frequency of the class preceding the median class. With this we are concluding this session. See you in the next session. Thank you.